Hi everybody, this is Eureka Math, Module 4, Lesson 13. Our objective today is to analyze and classify triangles based on side length, angle measure, or both. I think today is a fun lesson. I'm really enjoying teaching geometry. I hope you are enjoying learning it. The triangles are a lot of fun. So let's start with just some of the qualities of triangles. So here on the right, we have a picture of a triangle. It has 3 sides and 3 angles. This triangle we can call triangle ABC. The 3 angles of a triangle add up to 180. So 180 degrees. We need to remember that. That's just something we need to remember as we go through our lesson today. You will find that in each and every triangle you see. So like in the objective, we are going to classify these triangles by their side lengths and angles today. We're going to start with side lengths. We'll start with a triangle called an equilateral triangle. Take a look at the picture and think about what makes this triangle an equilateral triangle. I see that it has a root that is equa. And if you remember one of our word architects way back, maybe in August or September, that means equal. So an equilateral triangle has sides that are all equal in length. And it has these tick marks on each of the sides, these little lines that represent the equal lengths, the equal sides. There's something else that's special about an equilateral triangle. Let's look at a different one. Take a look. What do you see? Not only are the sides equal, but the angles are all equal. And if we remember from that first slide, the angles should add up to 180 degrees, and they do. So another important point about the equilateral triangle is that all the angles are equal in measure. Let's move on to the isosceles triangle. Take a look at this one. This is an isosceles triangle. There are 2 tick marks, not 3 like in the equilateral. So what do you think that means? You're right. It means that those 2 sides are the same length. So an isosceles triangle has at least 2 sides with the same length. So AC is equal to AB in this case. And if we drew or imagined a line of symmetry, we would be able to fold that triangle along that line of symmetry, and those sides would match up perfectly, which also tells us that angle C and the angle at B are equal. So isosceles triangles have 2 angles that are the same measure. So we've learned about equilateral triangles that classify triangles by their length, and isosceles triangles that also identifies triangles by their length, the side lengths. And we have one more, a scalene triangle. So take a look at these. What is different about a scalene triangle? What's unique about it? None of the sides are the same. And we can see that there are different tick marks on this. So we show that the sides are different lengths by having different tick marks on each side. So there are 3 ways we can identify triangles by their side lengths. We have equilateral, we have scalene, and we have isosceles. We are going to now identify some triangles by their angles. So here is a right triangle. Take a look at it and think about why this is called a right triangle. Did you think that it is because it is a triangle with a right angle? Because you were right if you thought that. So that is one way we can classify a triangle by its angle. Here's another way. Here's an obtuse triangle. And think about that. Take a look at the angles on this one. An obtuse triangle is a triangle with an obtuse angle. And it's important to note something else. When you see an obtuse triangle, there can only be one obtuse angle. And this goes back to knowing that a triangle can, the triangle's angles add up to 180 degrees every time. So an obtuse triangle can only have one obtuse angle because two obtuse angles would be more than 180 degrees, and you could not have a triangle with more than 180 degrees. Here's an acute triangle. Why would we call this angle an acute triangle? It is because it is a triangle with only acute angles. And if we added those three measures up, we would get 180 degrees. So those are the three ways that we classify angles and identify them by their angles. We're going to do that in the problem set. So let's head over to the problem set. I'm also going to go there. There's my problem set. Let's do a few together. All right. So number one, classify each triangle by its side lengths and angle measures. Circle the correct name. So each triangle gets a different classification. We both, they get a name, they get named by their side, and they get named by their angles. So I'm just going to write here at the top as a note, as a reminder, every triangle gets two names. Okay, they get one of these and one of these. All right, so let's begin. Let's look at A. I see what looks like, so let's look at the sides first. We're going to look at the sides. I see that there are two tick marks here, which tell me that these two sides are the same length. And I remember that a triangle with sides with at least two is called an isosceles. Equilateral means they're all the same. And in this case, we can see that one of those sides is longer than the other, and it doesn't have that tick mark. Now let's look at its angles. It's a very small angle. I can take my protractor if I wanted, but I can tell that this has an obtuse angle. I don't need to measure it. I can see because a right triangle would make a right angle. No, this angle is greater than a right angle, so that's obtuse. I'm going to circle this knowing that it is an obtuse angle. I'm sorry, an obtuse triangle. Let's look at this one, B. This one I see that its sides all have the same tick mark, so all the side lengths are the same. I'm going to highlight those tick marks really quickly. So these are all the same. So I know that is an equilateral triangle. They're all the same. And if you remember from the slideshow, an equilateral triangle had all the same angle measures. So we know that it is not a right triangle because there's no right angle. It's not obtuse. There's no obtuse angle, so they're all acute. I know that these are all the same. I'm going to take my yellow, do this. I know, can you guys see that? Yes, hopefully. All right, let's move on. I'm going to actually let you guys do these. Take a look. If you need to go back to the slideshow to remind you what each one is called, please do. Let's answer number 2 together. Triangle A, B, C has one line of symmetry as shown. What does this tell you about the measures of angle A and angle C? So we did have an example of this in the slideshow. So if we know this line is a line of symmetry, that means if we fold it in half, then everything will match up. So that means these angles are the same. So I'm going to quickly write an explanation. You can write my explanation or you can write your own. I'm going to say they are the same measure. I'm talking about angles A and C. The sides of symmetrical shapes have to match when you fold. Fold it. The angles will match. Okay, there's my explanation. You can have yours in your own words or use mine. All right, let's go down to number 3 here. How can the lines of symmetry help you figure out which angles are equal? So this kind of goes back to number 2. If we know that there's a line of symmetry and that the two sides will match, then they will be the same lengths and the same angles. So we can see this has several lines of symmetry, has 1, 2, 3. So no matter which side or which line you fold it on, the opposite angles will always be the same. They all have to be the same. So I'm going to put that in a little bit shorter sentence. So I'm going to say, no matter which line you fold, which line of symmetry you fold, the opposite angles will be the same. Okay? So no matter which one you fold of these dotted lines, those angles will be the same. So these angles, let's see, these angles will be the same because if I fold it down this, it'll be the same. If I fold it down this, then this angle and this angle will be the same. And let's see, I have a purple over here. If I fold it down this way, then this angle and that angle will be the same. It's a lot of different colors, but what this tells me is that this is an equilateral triangle. Each side and each angle are the same. So now we know that it's an equilateral triangle. That's going to help us with part B. It says that triangle DEF has a perimeter of 30 centimeters. Label the side length. Now, we know it's equilateral. We know that each of the sides, the perimeter, if you recall from our module, was it module 2? Perimeter is the distance all the way around. So the distance all the way around is 30. So we will divide 30 centimeters divided by 3 to get 10 centimeters. So each side is 10 centimeters. It tells me to label the side lengths. So this is 10 centimeters. This is 10 centimeters. This is 10 centimeters. Okay. All right, let's move on to the next page. If you feel I'm going a little too fast, please pause and rewind. All right, number 4. This time you will need a ruler or a straight edge to connect points to form 2 other triangles. Each point can only use each point only once. None of the triangles may overlap. 1 or 2 points will be unused. Name and classify the 3 triangles below. The first one has been done for you. So let's look at the one they did for us. It is triangle FJK. And they wrote it down here. By looking at it, they show that it is scalene because each side is a different length. And if you do have a ruler, you can measure that, or you can use the grid paper to see that each side is a different length. And because it does have an obtuse angle here, because a right angle would be right here, it's bigger than a right angle, it's an obtuse triangle. So I'm going to do one with you. We might have different answers if we all do them separately. So know that the triangle I choose to draw may not be the triangle you choose to draw. So I'm going to do this one with ABC. So taking my ruler and connecting these points to make triangle ABC. Of course, I can say it's triangle BCA, means the same thing. So I'm going to say triangle, let's say CBA. That's what I'm going to name it. I can see that all the lengths are different, so it is scalene. I can take my ruler and measure if I wanted to. I would like to use centimeters. I can see that is about 4 centimeters. That one is 2 centimeters, and then line AB is about 3 centimeters. So I have evidence that it is scalene. They are all different side lengths. And then finally, I see that this angle B right here, or angle ABC, would be obtuse. So I'm going to say that's obtuse right there. So I'm going to go ahead and let you do the next one on your own. You can choose, if you did this one like me, and then this is the example, to do another triangle in the middle. It can be your own choice. All right, let's move to number 5. Number 5A lists 3 points from the grid above that when connected by segments do not result in a triangle. Now, let's see. If I connected, I'm going to say, if I connected G, I, and H. You see this? If I connected G, I, and H, let me scoot that down. I'm going back up here. Take a look. So which ones would not result in a triangle? If I connected G, I, and H, I could not make a triangle. That would be a straight line. So I would say G, I, H. Those are the ones that would not be a triangle. Why didn't the 3 points you listed result in a triangle when connected by segments? They wouldn't be a triangle because when they are connected, they make a straight line, not a triangle. Okay. And finally, number 6, can a triangle have 2 right angles? Think about that. If we had 2 right angles, that would equal 180 degrees, and that would only be 2 angles. So the answer is no. Now, if we have 2 right angles, then we wouldn't be able to connect the 2 sides. Connect 2 of the sides. So I'm actually going to draw a picture of that. Okay, so let's see. I'm going to make a right angle using this little line that I already have here. So there's a right angle. And then I would like to make a triangle or another line. Okay, so there. I have made a shape with 2 right angles. Can I make this into a triangle? I can't. I can't make that into a triangle. These points, these lines would not connect. The only way I could connect them is to make a line across, and that wouldn't be a triangle at all. What would that be? That would be a square or a rectangle, some sort of quadrilateral with 4. So no, a triangle cannot have 2 right angles. All right, we have reached the end of our problem set. There were a few that you should do on your own and then return to our video here. There are the answers to the rest of number 1 that we did not do. Make sure you classify each triangle 2 ways, one by its length and one by its angles. We did these together, but if you did them on your own, here are the answers or sample answers. Here's an example. Your other angle may not look like that. Your other angle may look different. And that is it. Thank you for watching. I hope you had fun identifying, classifying triangles. I know I did, and I will see you in our next video, lesson 14.